I just did that whole part without having my volume on, so those of you that were listening, yep. Hopefully you just were able to read that because I was not talking with my voice on. So let's start with part B. We're going to now look for the change in entropy. You're given a table with the different entropies on it. So this one we're going to have to do products minus reactants and times it by its coefficient. So as we come down to the scoring guides here, if you take your, I don't know if I can get both of those on there, almost. Okay, scoot it up just a little bit, there we go. Okay, so you're going to take your products, which are your CO2, you take that volume, and that was a 1 in front of it, so I just put that minus my reactants. My CO just had a 1 in front of it, so that's this, plus half of my oxygen, so I do a half times the oxygen. So I'm timesing it by the moles, and that mole should drop out, and this should just be interesting, they kept the moles. Should be minus 86.5 joules per degree Kelvin, because we've already got the moles. But they're doing it per 1 mole of the CO2 being formed. So that's why the mole got kept in there. So you get 1 point is earned for taking 1/2 of the O2, and 1 point is earned for the correct answer with sign. So if we're looking at this, what does this tell me right now? So we have a negative delta H, which tells me what? It's exothermic, giving off heat. And I've got a negative delta S. What does that tell me? It's becoming more ordered. Good. All right, so let's look at C. On C here now, we have a standard enthalpy change, delta G. So we want to find delta G. We've got delta S and we've got delta H. We've got the temperature, so we just plug it into the equation. It's just a plug and chug. So we plug it through and we get a negative delta G. What does that tell me? Is the reaction? Other way, it's spontaneous. So negative delta G is just like a negative delta H. It gives off. It's going to happen. So we got 1 point is earned for substituting the values in part A and B. So as long as I substitute it right, and 1 point is earned for the product.
I got it wrong for the first two, but if I plug in...
If you plug those two in right, then you get this point, yes. Okay? So the next one, D, we go, is the reaction spontaneous? Well, negative is, so yes, it is spontaneous because we've got a negative delta G. You get 1 point. You got to say yes and why, though, not just yes. On this one, on E, it says calculate value of K. So now we're going to use the delta G, the equation that ties in K here, and we're going to solve for K. So we're going to tell delta G minus RT on the bottom, that'll equal ln of K. So once I've got that answer, then to get to K, I'm going to do base E of both sides. So I'll go E to whatever this is, and that'll give me KQ. Okay, you get 1 point for the correct answer, or correct substitution, 1 point for the correct answer. So I believe that's 1, 2, 3, 4, 5, 6, 7. Is that 10 on this one?
How many points were there for C?
C was 2 points. You got 2 points for A, so 2, 4, 6, 7, 8, 9. This is 9 points. Okay, so let's take a break, look at question 3, and we'll go through that in just a minute, unless you get stuck. Okay, so we've decided to go through this one step by step because a lot of them didn't know where to start. So here we go step by step. The first step is answer the following questions relate to the analysis of a chemical compound. A compound containing CHNO was analyzed when a 1.23 gram, 59 gram sample is burned in excess oxygen. 2.41 grams of CO2 is formed. The combustion analysis also showed that the sample contained 0.0648 grams of hydrogen. Didn't say anything. CO2. Okay, so the O is included with a C, the CO2. All right, so first thing we're going to do is we got to find out So first thing that we need to do is look at the CO2. So we have amount of CO2 in grams, but we need to find out how much carbon that is. So let's take our CO2, which is 2.241 grams of CO2, and we're going to change it to moles, because everything has to go back to moles, okay, in order to change from one thing to another. So we add up CO2, and it's like 44.08, something like that. We're going to take that as going. I can double check. Let's see. 44.01, sorry. 0.1 grams of CO2. And that's equal to 1 mole of CO2. So we're now at this point. I want to actually do this. So then we can cancel out grams of CO2. Okay, what do we do next? Where do you think we're going next?
So there's 2.
I want to get to carbon. I'm trying to get to carbon.
So you got to take away the mass of oxygen. So 1.
How about in 1 mole of CO2, how many moles of carbon are there? 1. So now I can get rid of moles of CO2, right? And now I can go back to grams. In 1 mole of carbon, there's 12.011 grams of carbon. Now it's just a matter of plug and chug. So 2.241 times 12.011 divided by 44.01. I think that's 44.008 is what I got it mixed up for. Okay, what do we get? 0 point something. You got 4 significant figures at least. You've got 5 actually right there. But we only have 4 in this one right here. Let me do a highlighter. In this one right here, we only have 4, so we can only have 4 in our answer right here. So we're going to put units would be grams of carbon. You okay?
Yeah.
All right, let's go to the next part, part II. In part II, it asks, when a compound is analyzed for N only, the mass percent of N is found to be 28.84%. Determine the mass in grams of N in the original sample. Well, this is just, if I got 28.84% on a test, and the test was worth 100 or 1.2359, how would I figure that out? Let's start with what I had, right? What I could have got, and what am I going to do? Right, or 28.84 divided by 100 to get it out of percent, and I would get my amount of nitrogen. I always don't trust myself in moving decimals on a test, so I always just do it the long way. So I know I'm going to be in 0 point something, right? Because 28% of 12, basically. So what do we get? Yep, 0.3564 grams of nitrogen. So that was fairly easy. We okay with that?
Yeah.
Okay, we're going on to the next part, which is II. Determine the mass of oxygen in the original compound. So we can do it one of 2 ways. We figured out the carbon. We figured out the nitrogen. We were given the hydrogen. So we can subtract all those from the beginning sample to find the mass of oxygen, or we can take the CO2 and convert it into grams of oxygen. So whichever way is easier. The way they've got here.
So the converting would be like the same thing we did on the first one.
Right, the converting where we found the amount of carbon, it would be like the same one, but we would go to oxygen. Okay, and we would, instead of having one carbon in one CO2, it would be two oxygens in one CO2.
And then it doesn't want the grams of O2, so then you have to make sure it's O and not O2.
Right, it's just O. So you would just, in 1 mole of O, there's 15.99. So you can do it either way. They show it this way. 2, 3, 5 minus, and we can double check both ways, 9, sorry, minus the grams of hydrogen, which was 0.648. We can double check it. Plus the grams of carbon, which was 0.6116, plus the grams of nitrogen, which was 0.3564. And that all equals 0.2031 grams. Let's double check the other way. So if I started with 2.241 grams of CO2, and again I went through 44.008 is what I remember it being, grams of CO2, 1 mole CO2. Okay, they just rounded up, got 4 significant figures instead of 5. Okay, and then I'd go here, and so for every 1 mole of CO2, there are 2 moles of O. And then for every 1 mole of O, there are 15.999 grams of O. So let's double check this and see if we get the same answer. We actually should, but let's make sure. We got an answer yet? Did we get the same one? We did not get the same one. Interesting. Yeah, I did too. Okay, so we're going to have to do it the other way. Interesting. It should have given us the same answer. Okay, so we're going to not do it this way, evidently. We'll just do it the other way, where we were given every single one, and we subtract it from the initial. I don't know what we did wrong there, but something. Okay, so the next one is to determine the empirical formula. So this is where we take each of the masses that we had. So we had, and I can't remember them all, so I'm going to pull them up here. We had 0.6116 grams of carbon, 0.0648 grams of hydrogen, 0.3564 grams of nitrogen, and 0.2031 grams of oxygen, right? We need to change each of those into moles. So, factor label. And I like to do all the setup first and then grab my calculator because it's a lot easier. Let me know if you get a different number than me, because I can easily mess up on calculators just as well as you can. Okay, so this is part of our mole song. Mass over formula weight, that's the way you get the mole. Then divide the largest by the smallest. So you take all of them and divide them by the smallest. The smallest here is the hydrogen, right? So you can divide them all by that. And I'm looking for a whole number. If I have a fraction that I know, like 0.33, then I've got to leave it. But if it's really close to being a whole number, then I want it to be the whole number. Yes? For the moles of nitrogen. Okay, double checking that.
Yeah.
0.0. Ah, so that's actually our smallest one. Okay, let's go back and fix that. Thank you for catching that. Oh. So we need to divide by the smallest one. The smallest one then is nitrogen. So 0.02544, 0.02544, 0.0255244. There we go. I can't say it, but it's written. So here we're going to get 1. Yes, shout it out as soon as you get them. Wow, 20. 22.5? Ooh, that's an ugly number.
22. No, for carbon I got 20, for H I got 2.5.
2.5.
Yeah, I got 2.
Something is messed up here.
I got 2 1/3.
Okay, let me look at these real fast. That first one should be 0.05.
Yeah.
I forgot the 0 again, because we shouldn't have 20. We double check on the others. I'm guessing the bottom one should be 0.0. Yep, it should be 0.01. Oh boy, we're messing up here. Good. So that bottom one is actually, the oxygen is the one we divide by. Yep. I'm just loving life right now, okay? This is just my lovely time here. Okay, so we need to go through and divide by the oxygen. You guys didn't catch me soon enough. Caught me on one, but not soon enough on the others. I have to have you guys do it all by yourself next time. At the end of the day, I get tired. Okay, so 0.0126. Is it 4 or 9? 9. Okay, what'd you guys get for these numbers? I'm tired of doing them already. We should have got 4, a 5, a 2, and a 1. Is that what you guys got? Okay, so the empirical formula, we just write C, 4, H, 5, N, 2. Oh, we got our empirical formula. Okay, so on the first one, on I5, determine the empirical formula, you get 1 point to just convert it to moles. So if we convert them to moles, so we got 1 point. if we divide them all by the smallest, then we got another point. And then when we actually wrote the empirical formula, we got another point. So that was worth 3 points.
And that's all the moles?
That's all the mole song. Yep. That's all the mole song. Okay, let's look at the next one. So the next one then gets into a different compound which has an empirical formula of this and a density of this. Use the data to follow the molality of a compound. So we want the molarity, which is moles per liter. So again, we're going to go back to Pervnert. And molarity is just N divided by V, right? That's equal to molarity, which is then equal to, so I want the RT on this side, B on that side, P on that side, so we go P divided by RT. Is that right? Did I convert it right? So RTs would need to be divided by both sides.
For molarity?
We're solving for molarity, yep. I believe, let me see. Oh no, we're solving for moles, sorry. I just got molarity all mixed. Yeah, let's solve for moles, it'll be easier. And then we can solve for moles. Now I need a big eraser. Okay, solving for moles would be a lot easier. Let's do that first. So N is equal to PV divided by RT. Up here we have P, we have T, we have density, which is grams per liter. So that's why I was thinking molarity, because I can change that to moles per liter pretty easy. Okay, use the molar mass. So I've got, I don't have volume, right? So let's change that, take the V off this side. Let's solve for molarity, and then we can change it. Then we can get it into moles. Let's do that, it's a lot easier. Okay, so we got pressure, 0.983 atmospheres divided by R, 0.0821 atmospheres times liters divided by mole times Kelvin times by temperature, 375 K. K goes out, atmospheres go out. We've got 1 over liter per mole, which will end up being moles per liter. So let's go ahead and solve for that.
That's 0.319. Yeah, that's what
0.0319. Let's carry one more. Okay, this is moles per liter, right? And we still have the density up here we have not used. They want us to find the molar mass. What's the definition of molar mass? Grams per mole, right? So we've got 1 over. So what if we do, now take that 6 grams per liter. The liters will cancel, and I'll end up with grams per mole, right?
$187.91.
187.91, and that would be grams per mole. See how close we came. 188, because 3 sig figs. So 188 is the right answer, grams per mole. Oh, we don't circle. 187.91, 188. Okay, let's go on the next one.
So let's say that like the numbers were weird and you couldn't remember how many sig figs. So if you just wrote the answer with a whole bunch of times with a different number of sig figs, would you still get the point?
No. Okay, you only have one sig fig point. You don't know what problem it's going to be on. So if you, when in doubt, use what you think it is. Don't just give me multiple answers. Because if you give me multiple answers, I have to choose the first one. Okay? So molecular formula of a compound. So let's look at this one. So for each, this is the, so empirical versus molecular. We just found, let's see, molecular formula of the fat compound. We found the compound, they gave us up there CH2Br. So CH2Br. And we just found the mass, right? 188, right? That was from the last part we did, 188 grams per mole. So I'm going to add this up really quickly. I got a carbon, basically 12, and this is the one that you can do fast. So 12 plus about 2 plus about 80, that's going to give me what, 94? Okay, this is a quick one because we just want to see how many times it will go into it. And it has to be an even number, or it has to be a whole number. So then I go, oh, how many times will 94 go into that? 2. So molecular formula, I just taken times each of those subscripts by 2. C2H4Br2, done. Easy point, easy point. And that's the end of that one. Yes? All right, so that's the end of today because we're at time. So you guys did a good job.